Grounding the electrical system of a residence is essential for safety, as it provides a low-resistance path for electricity to flow back to the ground in the event of a fault or surge, protecting people and equipment. The most common methods of grounding transformers for residences are firstly, delta transformer with isolated neutral. In this configuration, the primary winding is connected in a delta configuration, isolating the neutral point from the ground. A separate grounding electrode is then installed to connect the neutral conductor to ground. Secondly, Y transformer with center tapped neutral. The primary winding is connected in a Y configuration and the neutral point is directly connected to a grounding electrode. The grounding wire observed running up the mast is an uncommon but acceptable method of grounding a transformer. Here's how it works. The ground wire provides a redundant grounding path. It connects the neutral conductor of the transformer at the mast to the main grounding system of the house, which typically includes a grounding rod driven into the earth. The connection to the mast improves the grounding efficiency because the mast is typically grounded by being buried in the soil or connected to a grounding rod. This provides a low resistance path to ground even if the grounding rod is damaged. The ground wire is bonded to the mast. This ensures that the neutral conductor and the mast are at the same electrical potential, preventing any potential differences that could create a safety hazard. While it is not the most common method, there are a few reasons why a power company might opt for grounding the transformer using a ground wire on the mast. Firstly, difficult soil conditions. If the ground rod cannot be properly driven into the soil due to difficult conditions such as rocky or frozen ground. Secondly, accessibility issues. If the grounding rod cannot be easily accessed for maintenance or testing. Thirdly, additional grounding protection provides redundancy and improves the overall grounding system reliability. It is important to note that the grounding wire on the mast must be properly installed and maintained to ensure its effectiveness. It should be adequately sized, tightly connected, and protected from corrosion or damage. In summary, grounding the transformer using a ground wire on the mast is an acceptable but less common method. It provides redundant grounding and improves grounding efficiency, but it is crucial to ensure its proper installation and maintenance.